Okay, so good morning, everyone. While hopefully others will trickle into. So today's lecture is by two of my students. So this is Chengguang Shen, close to graduation. Bo Zhang, he is in early stages of his PhD. What they're going to do is to walk you through how to develop sensor-oriented applications. Okay, so some of you may have probably developed some sort of app on iOS or Android, possibly, and many of you probably haven't even done that. It's fine. So what they'll do is this is more of a tutorial, show and tell, walk you through as to what's involved in an application development, but particularly so for an application which makes use of sensors. And phones have some sensors built in, a whole bunch of them, a dozen or so in a typical phone, as well as through various kind of wireless mechanisms, typically so-called smart Bluetooth. You have other types of sensors that the phone talks to, and then, of course, phone itself then kind of goes, can do processing and all. And then these off-board sensors, some of them are really, really dumb, and then just some simple sensors like a heart rate belt or something like that. And on the other end, you have smart watches which have come out, which can do processing locally as well. And as it turns out, the application development, at least on Android type watches, is pretty much the way you develop apps on the phones. It's the same operating system, same kind of procedure applies, and watches, of course, have different sensors. So they'll walk you through that process, and then also show a couple of sort of sample applications on what happens. Now, in a typical setting, what would happen is that on the phone itself, besides collecting the data, you'll probably also do some sort of classification, regression, some processing on the sensor data, and then oftentimes send the result back to the cloud. Do you show any of that, like stuff going on?
Yeah, to the FTDD and to trigger some rules.
So they also have an example of how to send data back to a cloud service, and that's kind of a typical end-to-end application that we have. Later in the quarter, they will visit us again, and the idea would be to kind of go into OS details of Android architecture itself as an example of a modern OS. So with that, let's start.
Yeah, thanks for the introduction, Mani. My name is Chen Guang, and today I'm going to cover this topic of Android app development. And so I just want to first say that this will serve mostly as an introduction to most of these topics covered in this lecture. So I will provide some links and pointers, and if you feel interested in some of the topics, just you have to go dig in yourself. And this will be mostly be high level, but we'll also include some hands-on demos to show how everything works. And feel free to interrupt me if you have any questions during any stage. And yeah, so mobile phones today, they are not only just communication devices, they start to become more of a sensing platforms and computation platforms. First of all, they are everywhere. We have 2.6 billion smartphones in 2015, and we expect to have about 6.1 billion by 2020. And each of the smartphone now is shipped with a multi-core processor. Like you might know all these news about the ARM Big Little architectures. Basically, each of them has multiple cores, multiple brains, and the phone also has multiple ways to communicate and interface with humans. There's of course the touch screen, but you can also do speech control like the Siri and Google Now, and also you can do haptic control. And like if you have the newest iPhone, you might also have the gravity-based touch control. All these things has really changed the way you interact with a smartphone. And of course, they have many built-in sensors. That might be something you will need to use during the course project this quarter. So they have motion sensors, orientation sensors, and even some sensors that can measure environmental conditions, and also maybe things like heart rate sensor that can measure your health conditions as well. Phones also have radios. They are not only for communications, but some of the radios can be used for sensing proximity to other phones and nearby objects. Like Bo later on will show an example of using the phone to communicate with some Bluetooth beacons, and also your Android phones are also shipped with all these NFC tags like the Apple Pay you've been using, and also you can use Wi-Fi to get information about all these access points. Maybe that can tell you the location, the rough location you are in. So all these radios, they're not only just a way of communication, but you can use them as sensors as well. And finally, your phone has cameras and coupled with powerful CPU and GPU. There's a lot of things going on in terms of augmented reality and virtual reality you can do using your phone. Like you might have heard of the cheaper version, the Google Cardbox, the more expensive version, the Oculus VR, or the Samsung Gear VR. So all these things, they're really just like a placeholder for your phone, but the real work is going on using your phone's CPU and GPU and all this stuff. So yeah, here's just a list of examples of sensors and possible inferences from smartphone. By inference, I mean any kind of user contacts, any information about yourself, your location. We can call this inference. Like you're using your location sensor, we can not only figure out the traditional place and location, we can probably also know that who you are with, who your friends are, and what are your shopping habits, your eating habits, and all this stuff you can know from the location or your location history. And we have the accelerometer on your phone and other inertial sensors such as the gyroscope and gravity sensor. So these sensors can give you information about not only your movement type, which is obvious, but you can think of like people have been working on trying to infer the typing you have on the soft keyboard just from the pattern you vibrate the phone, you touch the phone, and also people have been mounting this phone on your dashboard in the car and see what is your driving habits. Are you doing some aggressive driving? So those kind of inferences. And on the far left corner is the microphone sensor. So you can, of course, you use a microphone to do voice control on your phone, but that can also tell a lot of things. Like for example, your ambient environment. What kind of environment are you currently in right now? Are you in a classroom? Are you in an office? Or are you in a public space? So all sorts of information can be figured out from the microphone data. And finally, you can also connect external sensors to your phone using Bluetooth. And researchers have been working on developing all these health-related sensors that can tell your stress condition, your conversation states, and even your smoking and drug intake habits. So yeah, really a lot of things going on in the space of sensing using smartphones. So in the next few slides, I'm just going to give you some basic examples of using commercial phones for sensing related tasks. So this is example on the right. This is sensing system. So on the bottom, this is a sensing system developed by the University of Memphis. So it's called AutoSense. So it's like a chest band type of stuff. You wear it on your body, but it will give you continuous measurements of your health-related signals like ECG and respiration, and therefore they will use those information to inform your conditions such as stress and smoking and conversation and stuff. And on the right is their architecture for doing this mobile health, so-called mHealth. And basically, as patients, you can use those sensors to collect data about yourself and report to your physicians, and then they can use this information to better help you manage your health conditions. And yeah. And next example is actually from UCLA. So I believe this is Professor Osgan's EE lab. Sorry. So they are basically trying to connect a sensor or external sensor custom developed by themselves to a smartphone, so that you can use this sensor as a as a microscope to investigate all this chemical stuff. So before you might need very expensive devices to conduct those experiments, but now you can just have a relatively cheaper sensor attached to a phone and use your phone as the processing power to do those kind of tasks. And another example is mobile collaborative computing. So in this example, researchers have developed an app on the phone that use a camera to figure out what are the states of the next traffic light. So if you mount it on your dashboard, it can figure out if you should accelerate or you should hit the brake so that you could save some gas until you hit the next traffic light. So this is like intelligent scheduling of your driving habits, and people have also been doing things like they have used the front camera to try to look at your eyes and see if you are falling into sleep while driving, so that it will give you some notifications and to ensure safety. So this is really like a cheaper version, because you see some of these features on some of the new or high-end cars where they can detect the lane departure warning and like blind spot detection, those kind of things. But using the smartphone mounted on dashboard, using the front camera, they can achieve something similar like that at a much lower cost, of course. So yeah, after some examples, I just want to first show why Android, how popular is Android today. So like Mani mentioned, this time we'll not go into the details of the Android operating system, but we'll just cover most about Android application development. But for the lecture in May, we'll talk a little bit more about Android systems. So Android is initially developed by a startup called Android, and it is then acquired and being developed by Google after that. And the first OS is released in 2008. So yeah, this thing is a little bit out of date right now. Now we are actually at version 6, which is called Marshmallow. And it is a Linux-based operating system and supports all architectures, including ARM, MIPS, x86, and it's also open source under Apache license. So yeah, you can always go to the Android website and download the source code and play with it if you like. And the apps are written in Java, and there are about 1 million of them. I'm sure right now the number of apps on the Android market has surpassed this number, but yeah. So here is a figure of smartphone market share in 2015 second quarter. So as you can see, Android is taking like 83% of the market share, which is very huge. Maybe you don't feel like that way here, but actually maybe in countries like developed countries like China, Android phone is really taking a big market share in recent years, and is squeezing the market share of iOS as well. So here is a list of Android releases from 1.0 all the way to the latest 6.0. So what I want to show you here is that we really have so many versions and so many different SDKs from all these different versions. And the interesting thing here is that they name each of the version using a dessert name, from cupcake to like gingerbread, and to the recent ones lollipop and marshmallow. But one bad thing caused by all these different levels APIs is that since you have a new API level almost every year, you will have some problems associated with the development because for each API, it will introduce some new functionalities and maybe deprecate some old ones, and you probably run into issues if you want to be compatible with all these previous versions. So just to show you an example, this is a figure trying to visualizing the fragmentation of the current Android ecosystem. So here each color corresponds to a version of Android OS. So of course also Android SDK. So this figure is being generated in August 2015. At that time, the latest version is still 5.1, but you can see this is the market share of the latest version. You can see it's almost, it's definitely less than 5%, maybe like 2% or something. And even at that time, you can still see big market share is still taken by API levels several years ago, like 4.4. So what this means is that when you develop an application on Android, you really have to consider all these people using the older operating system, and you have to figure out a way to make your app both work for the latest version as well as being compatible with the earlier version. So the fragmentation is also is really an issue for all these Android developers. And not only OS version, there's also issues on fragmentation of devices. So not like the iPhone where you have only one vendor. For Android, you have a lot of vendors, and their copy of the Android system may differ a little bit from each other. So this is also something you need to consider when you develop an app for Android. So yeah, just some other figures trying to characterize the fragmentation of Android. So here is the screen size of all possible devices available in the market. So if you think about the iOS ecosystem, you only have, say, iPhone 6, iPhone 6 Plus, and maybe iPad, iPad Mini, and now you have iPad Pro. So you have, I most say, 6 or 7 screen sizes. But for Android, you have all these different screen sizes. So when you are developing a UI, you really have to consider what my app is going to look like on all these different screen sizes, which might be a big problem for you. And on the right here, I'm also comparing the market share of different operating system versions between iOS and Android. So in August 2015, iOS, you can see pretty much there are only two candidates, iOS 8 and iOS 7, but for Android, you can see there's all these different versions available. So yeah, this really like a big problem of this fragmentation compared to iOS. So just keep this in mind, and this is like a system overview of the Android. On the lowest level, we have the Linux kernel, which is like a regular Linux kernel, and on top of that, we have an Android system stack implemented in C and C++, which runs on top of the kernel. And on top of the system stack, there is the application framework, which is implemented in Java, and which also provides the API for all the applications to use. And finally, we have all these millions or billions of applications running you can download from the App Store. So in this lecture, we're mostly going to cover application framework and how you develop an app. And in the lecture in May, we'll talk about in detail how the Android system stack works. So yeah, for application framework, there are mainly 4 components we're going to talk about: activity, service, content provider, and broadcast receiver. So first of all, the most common or the first application component you will see is the activity. So it is a single focus thing that a user can do corresponding to one UI screen. Basically, one activity is one UI screen you can see when you open an app, and it is the part where the user interact with the app. Normally you will think you will do some UI task in this component in your activity, and you are not trying to do some heavy processing or network communication or file accesses in an activity. So the lifetime of the activity is defined by multiple callbacks. So the way you implement an activity in Android is that you inherit from extend Android system activity, and then you can implement all these callbacks, or I should say you can override all these callbacks, and then you can get notifications of these state changes and decide what you need to do at each stage. So there are several lifetimes of an activity. So the entire lifetime is from create to destroy. So basically that's defined by 2 callbacks on create and on destroy. This is the part where the activity got created and got destroyed regardless of whether it is visible or not. The second state is called visible. So it's defined from onStart to onStop. So visible, it could be partially visible or fully visible, but it doesn't have to be on the foreground or being able to interact with the user. And the final state, or the most common state, is a foreground state. This means it is being able to interact with the users, and there's nothing hiding this activity. Like for example, when you are running an Android app, probably some notification popped up and you want to look at the notification. And at that time, because the activity is partially hidden by the notification bar, then you are in the visible but not the foreground state. But after you look at the foreground, after you look at the notification, you put that bar back top, and then you start focusing on this app again, and node activity goes into the foreground state. So the reason I noted out all these callback functions is that those are something you'll always use when you implement an activity. For example, if you have an app that has a text field in it and you let the user input some text there, well, when the onPause function being called, that means this activity goes into the background, or it's being hidden by something. Then you need to find a way to store all this information from the user, so that when it resumes become visible, you can get this stored information and restore it on the screen, so that the user doesn't lose anything on the screen. So this is just a skeleton of an activity in Java code, which you will implement in your Android app. So like I said, you will inherit from Android system activity. And here is an example of writing the onCreate callback function. So this is the part where the activity is being created, and the part where I need to define what are the UI components required in this activity. So the way I'm going to do this is you have to implement an XML file which defines the layout of that activity, and you need to load this XML file defined for the UI when you during the onCreate callback function. So I just want to talk a little bit more about how you implement an UI in Android. So the basic component of Android UI is called view. So views are GUI controls. It could be text view, it could be a button, it could be a edit view, so all sorts of things. And your activity UI will just consist a bunch of views and view groups. So you can perform a set of operations on a view, including you can set in the properties, you can set in focus, you can set event listeners. So this is important, as you know. Android and all these operating system for mobile embedded devices are like sort of event-driven systems. So whenever some event happen, like you click a button on the UI or there's some information from the internet, all these things can be defined as an event in the app. So the event listener is a crucial part where you do things or where you interact with the user. And also you can set visibility and etc. All these operations on views. So Android has provided some default layouts for defining all these views, and some of them I have listed here. Like linear layout, you can list all your views in a linear fashion, either vertically or horizontally. Relative layout, you can define the relative positions of each components, each views. Like for example, for this one, you can say I have this big block here, and I have this small bar here, which is on the bottom of the big block. I have this smaller bar here, which is to the right of the bigger bar, but to the bottom of the big block. And also there are other views like list view and grid view. This is basically some approaches for you to organize all these views in Android UI. I guess the most popular one you will use is linear and relative layout. So this is an example of Android Layout XML file. So as you also see later on in the demo, this is how you basically define a UI. So in this one, it's pretty simple. It's just linear layout, which is vertical, and it contains two parts. The first part is a text field, which is like a label, which says hello and a text view, and the next part is the button, so just something the user could click. And in this, so for each of the component, you need to define some properties like the width and height and the text for text field. And in this linear layout, because it is vertical, these two components will just be placed vertically next to each other on the UI screen. So there's one thing you need to keep in mind about defining XML file is that all the constants like strings and dimensions and color codes, they should be defined in separate files, not like this. It is generally not a good practice to write string literals in this XML file. You should always define a separate resource file like strings.xml or dimensions.xml or even colors.xml and put it into a folder called values. And here you can just use add strings slash the name you define in that file to refer to the strings. So this is mostly for either for the elegance of the code, or there's another important part, which is if you have multiple buttons that can share the same text, defining it in the separate resource files will help the compiler better make the size of the code more compact during compile time. So another thing I want to mention is the Android material design. So before Android 5 or API 21, people, like some Android developers, always complain there's no very good UI design guideline compared to iOS. Like iOS provide all these guidelines for you even from very early stage, like how should you place each UI component and how should you organize your app so that it looks uniform on a phone. So this is before the fashion people develop Android apps is very ad hoc, but since then Google have released this Android material design guideline. So it's like a comprehensive guide for visual, motion, and in-action design across different platforms and devices. So you would think if you comply to the rules in material design, your app should look uniformly or consistent across different devices like your Android phone, your Android tablet, or even a Chromebook. So yeah, it includes a bunch of things like it suggests you how should you size your UI components, what should the dimensions of each UI component like buttons and text field be, and how should you place your components next to each other. And they even include a library of fonts and icons you can use. And the material design also provide a set of themes you can use, and you can also inherit or override some of the themes and define your own. Like instead of defining separate colors for components on a UI screen or in an activity, you can specify different colors like color primary dark, text color primary, and navigation bar color. So you don't have to specify where exactly should I put this color, but you just need to give color to all these labels, and the material design library will try to figure out what are the best place to place each other so that it can look more natural and consistent. And here in this XML, I'm just showing a way you can define new themes and maybe inherit from existing themes. So the way you do that is you can have different items, and for each of the item in the theme you define, the name is that property you have shown here. Like for example, here you have property called Android Layout Width, and here you can say there's an item which with the name Android Layout Width and with the value of web content. And once you define all these themes for different components for different views, like this one, I call it my text view style. And later on, if you have a text view here, you don't have to write all these property anymore. You can just say that style equals my text view style. So even if you are doing very simple apps, I suggest you should take a look into this material design guide and try to make your app's design and UI comply to these guidelines so that you won't run into trouble in the future, and also you have a good practice of designing the UI. So after activity, the second second component is called service. So activity is the foreground part of the app, and service is the background part of an app. There's no interaction with the user, and the task of the service is just do something, do some computation. And even that, just keep in mind that the service also runs on the main thread of the process. So you shouldn't really be doing anything that's blocking. And if you want to do some blocking or asynchronous task, you can use this separate task called async task, such as for downloading some stuff or trying to write some files. And later on in both demo, you will see the use of async task as well. So there are two forms of service, two ways you can start running something in a service. The first way is like a more async fashion. you started by calling this function onStart command, and then the service will start constantly doing something, and it will not return the results to the caller. Basically, you tell the service to start doing something, and it'll finish when it finishes. It will not tell you, and you might have to implement some other mechanism if you want to know the results. And the second way is more like a control fashion. It's called bind. So your other components, application components like activity or even other applications can bind to your service. And after you bind to the service, you have a handle to it, and you can call all these functions. And the service can, of course, also return some results back to the caller. So this is the way more like a client-server architecture from the binding. So this is the skeleton of the service, also in Android, in Java code, and you also write a class to inherit Android system class called service, and you implement all these callbacks like create and destroy, similar to the activity one. So just keep in mind that whenever you need to do something blocking or asynchronous, try to start it with a new thread, not to block the main application thread. And the third application component is called content providers. So content provider is like a lightweight database for you to store and retrieve data from the application. So it is able to manage access to structured set of data because it uses SQLite as a backend database. And you can also try to manage external resources from application code. So you could perform or SQL-style operations like insert, update, delete, query, those things on top of the content provider. So it is the standard interface that can connect data in one process with coding running another process. So you could think of all these things as resources, including images, strings, layout files, and the way you manage those resources is that they are mapped by the SDK2 into an ID. So it's like a key value store. The actual content could be in a content provider, and ID will be generated by the compiler, and you could use the R class generated by Android SDK to refer to all these resources by their IDs. And this one thing I mention is the binder APC mechanism. I just want to briefly mention it here because we'll go into details of the binder mechanism of Android in our next lecture. But in general, binder is for IPC, which is inter-process communication among apps or even between application and operating system. So in Android, in general, each application will run its own process, and the system, all these OS services will also run its own process. And if your application want to retrieve some information from other apps or from the operating system, say for example, you want to do authentication using a Google app, or you want to fetch the location data of the user from the operating system, you will have to communicate to another process, and you will need some inter-process communication mechanism. So in Android, this is implemented by binder, and while we're not going into details about binder today, we'll talk about the high-level delegates of binder, which is intent and intent filters. So intents are high-level use of binder, and it is like a message used to active and pass data between activities, services, and broadcast receivers. And each intent will contain an abstract description of the action along with actual data in it, and it can also contain information about the potential recipients. So there are two types of intents available in Android. One is called explicit. This is where when you send an intent, you explicitly specify where this intent is going to. Basically, you specify the target of this intent. And the other one is called implicit. This is like you don't have any explicit target of intent, but you can specify some action strings in the intent so that later on, anyone with the similar or with same actions could receive the intent. So this each of these type of intents have some actual usage scenarios in Android. For explicit, for example, before I talk about the way you invoke a service from activities. So if your activity want to start a specific service, like my foreground UI want to start a service to do the exact service to do some sensing tasks on the user, I have to use an explicit intent and say that I want to start this exact service. But the implicit intent is also used for, in some cases, for example, the system sometimes sends some broadcast intent to all the applications. I'll also talk about that later in the next slide. But for example, you want to send the battery state to all the applications to tell them right now the system is running low on battery, so you have to save some power. So in that case, you don't have to say who am I going to send this intent to, just to say that whoever wants to know this information, I should let this app know that the system is running low on battery. So yeah, both of these cases are useful when you run an application. So finally, you can also specify an intent filter from activity service or even broadcast receiver. So this is the part where you specify what kind of implicit intent they want to receive in your application. So you can specify what categories of intent, what is the data type, or the actions of the intents you can receive, and only the matching implicit intent will be received by you after you implement this intent filter. So we have covered three parts, three components: activity, service, and content provider. The final one is the broadcast receivers. So this is an Android implementation of a system-wide public subscribe mechanism. So the system broadcasts events all the time. Like I mentioned, it could be when the system is running low on power battery. So actually, if you look into details of the Android system, whenever the battery percentage changes, like even from 99% to 98%, the system will generate a broadcast to all the applications, and whoever has that corresponding intent filter will get that information. Other examples include, for example, if the system is searching for Wi-Fi and finds some Wi-Fi network that has open access, it will also publish this. It will also broadcast this information to all the applications saying that there's an open Wi-Fi network. So the receiver itself is like a dormant code that which will only get activated once the intent is subscribed to happens. So the broadcast can be either asynchronous or ordered, and there's two ways for you to register and broadcast receiver in an application. You can either do it dynamically in the code or statically in a manifest file, which I will show you in a second. So after the four application components, this one final thing I want to cover is called the wake lock. So this is about power management on Android. So since the default Android power management is designed to save power of the whole system, so it will try to opportunistically go into a system sleep or suspend state whenever possible. So if you have some kind of continuous app running, this could force your app to stop. Even this will cause some functionality errors in your code. So the wake lock mechanism is just for avoid this kind of situations where you can actually write a wake lock and say, whenever my application is running, just don't go into sleep, or just don't turn off the screen, or even just don't turn off the CPU, but you can still have the screen turned off. So you can specify different level of wake locks, but the way you do this is you can get a handle to the wake lock and say acquire, and after you have done your task, you can say release. But before this time span, between the acquire and release, the system will not go into sleep or based on your description of the wake lock. So this is something which might be very useful to you if you are developing some continuous sensing or computation apps. But this could also be something very dangerous because there's when you are developing an app, some people tend to forget to call this wake lock release function, which means the acquired wake lock is never released and it's always blocking the system from going to sleep. So this could greatly exacerbate the power consumption of the system. So you should be very careful when you use things like wake locks. So I have covered some of the most important Android components, and we can start to see how we can make an actual Android app. So first of all, I don't know if you have heard this, but the official IDE for Android right now is Android Studio. If you download it, it will also include the Android SDK. And if you want to have some native modules in C or C++ to interact with your Android app, you also need the Android NDK, which is a native development kit. And after you have downloaded SDK, you have to update to the latest SDK tools and platforms. By platform, I mean all these API levels I showed in the earlier table. So each API level will correspond to a set of SDK libraries, and you have to download them using SDK Manager inside of the Android Studio. So the way you do this compile of Android app is that from the app, it will be compiled and packaged into an Android package file, which is .apk. This is the actual application file you will install after either you download from the Play Store or you do it through your own Android Studio. So it will include several components, including the actual binary code of the program, some resources, and the most important thing here you will see is the Android manifest XML file, which you will see in a second. This is like a overview of your Android application, and you have to define it. You always have to define in your application so that each of the component will work. And if you want to publish it to the App Store, you also need to do some signing. And if you just want to play with it on your own computer, you'll just use the default debugging key to sign it. But finally, you will run your application to our device or emulator using the ADB tool, which we'll also cover later. So, like I said, Android Studio right now is the official IDE for Android development. It used to be Eclipse plus a plugin, but right now the Android Studio is a much better and more organized way of developing Android applications. So I can give you a simple example of creating a project in Android Studio. Yeah, this is the starting UI of Android Studio. You can click one of the existing project, and you can also start a new project. And there's several things you need to do when you start a new project. For example, you need to specify the name, your company domain, and one thing you need to keep in mind is you need to pay attention to is this package name. So in Android, this package name is the only thing that's uniquely identifying your application from others. So this name basically will be the name of your application to the system and to other applications once this app is running on the phone. So you have to basically you need to just try to generate a unique name of yourself, and also this name should always mean something. Either it could describe your organization, your affiliation, or it could try to describe the functionality of the application. And you specify project location. And here is the interesting part. So there are several different platforms you could specify, and it could be the regular app, which can run on phone and tablet. It could be a Wear app, which is the Android Watch application, and there's also other interesting applications like TV and glass. You can also use the same Android Studio to develop applications for Android TV and like the Chromecast and also Google Glasses. And for each of the platform, you need to select the minimum SDK supported. So remember, since we have the latest Android SDK and Android Studio download, the target SDK or the target in which your application will be compiled with is always the latest one, which is API 22 or 23 right now, Android 6.0 Marshmallow. But you also have to specify a minimum SDK number, which is the minimum level of Android system you will be backward compatible to. So, like for example, when I select Android 5 Lollipop here, it says only about 35% of the devices currently on the Google Play Store will be able to run your app. So that means, say about 65% of people are still running a version lower than Android 5. So this is really a trade-off here. Say if you select 4.4, you can see that you can support up to 70% of the users on the App Store, but then because you are using a lower number of minimum SDK, you will have to have more restrictions when you use some of the newer API introduced in later versions of Android. So that's something, this fragmentation issues come into play when you're actually developing an app. But this figure is also changing rapidly. So you can also, Google also provide some guide for you to choose, like what will you lose and what will gain on selecting a lower or higher different levels APIs. And you can see from this list if there's really something you need in your application. If not, you can always try to be more backward compatible to even a lower version. And after you have select this minimum API level and all these platform you want to support, you can choose the default activity, which is like the entry point of your application. This is like the main class in C or the public void main in Java when you write a simple, or the main function in Python when you write a simple desktop application. This is the first activity you will see when you click the application icon on your phone. So there are all sorts of templates provided by Android. You could be the navigation drawer, which is like all these Google apps you see on Android, or also on iPhone. You click some button in the on the corner, and there will be a navigation drawer coming from the left. And also you can do a Google Maps activity. And yeah, all these templates is pretty handy when you if you are actually trying to develop a real app. I'll just select anyone because it's just for them demonstration here. And you specify a name for the activity and also the associated layout file, which I mentioned a while ago. So this is the place where you define the layout XML, and this is the actual Java code that is going to load this layout file. And finish. Yeah, this Gradle system is an open source build system for Android right now, and I'll also talk a little bit about it later. So if you look at this application here in this window, it has several components. First of all, the project we just created, which is a project, is like an overall project here. But the real application you have is called a module here. It's called app. It's a default module of in this project. You could have multiple modules inside a single project, and you can name them differently. And they can also be different, be targeting different platforms. Like in one project, you can have different modules. Application 1 is for phone and tablets. Application 2 is for wearables. Application 3 is for Google Glass. That's fine. And you can also have modules that is not for a specific platform, but just a library module. For example, you can have a module that's specifically designed for computations or scientific computing, and then you can include that module in other modules as a library. And just look at this application, this project. You have several top-level things. One thing you need to notice is this settings.gradle. Here it is the part where you define how many modules are there in your project and what are the names of each module. So here we only have one module called app, so it just says include app. The other part is the top-level Gradle file, which will be used for building this Android project. So normally you wouldn't need to change this top-level Gradle file because you also have a Gradle file inside of each of the modules, which will be more useful. But in general, in this top-level one, you'll just specify the version of the Gradle. Gradle is like a tool for automatically building. So you specify the version of Gradle, and sometimes you'll notice that, for example, you will say write this app using Android Studio 2.0, and later on, if they release Android Studio 3.0, they might be using a later version of Gradle than this 2.0. So sometimes you have to update the version number of the Gradle here. So for top level project, this is the two important things: settings.gradle, build.gradle, and also you need to know that it includes a bunch of modules, which is the actual applications. But inside each application, this is the real part where you implement your app. So first of all, there's this Gradle build file for this module, this application. So like I said, you have to specify the compiled SDK version. So here it is Android 6, which is 23. And there are some other configs, like the module name you specified when you create the application is being defined here. This is like an application ID, which is like a unique identifier in the Android operating system. And you need to specify the minimum SDK version, like you have chosen when you created the app. You can also change it here later on if you change your mind. And some other stuff. For example, this one, ProGuard. So this is something which can be very useful if you're really trying to publish your app to the App Store. So this is, by default, Android compiler will try to make the application code more compact because some people may not have that much of memory available storage available on their phone. So it will always try to make the size of the app smaller when compiling a file. So here, the reason you need to include this ProGuard is that maybe some of the class you define in your application wouldn't be used in your code, and the Android compiler will be removing those class files when you actually compile the file. But maybe this is something you really want to keep in the code, and you don't want the compiler to remove those things, even it is trying to minimize the size of the app. So you define those ProGuard rules to say that I don't want those classes to be removed. For example, here this is the ProGuard rules. It's not including anything here, but you can always define some class here, like your own classes. If you include it here, and you have this ProGuards minify invoke to true, then it will be you will look at this ProGuard rules file, and the compiler will not try to remove all these classes you define here, and will always keep them in the final source code. And finally, the most important part, or the part we'll be using the most in this build Gradle file, is the dependencies. So if you have programmed in Java or even Android before, you will know that the normal way for you to include a library is to include a jar file. That can be problematic sometimes because the jar file, if you update the library, you will have to replace the jar file. There's no way for you to automate this process. But starting from Android Studio, the Gradle building system uses this dependency block for you to use the Maven style to include all these dependencies. So Apache Maven is the system for open source system for building as well. So Gradle supports a similar fashion to include a third-party library in your application. So for example, one thing you could, let me show you an example here. So this is a demo we'll be showing you later in this class. So in this demo, we are trying to make some network HTTP access, and since there's no very good HTTP library in Android, which we're trying to include a third-party HTTP request library. So if you search for this repository on GitHub, you can see that it supports Maven Central, which means this library is available on the Maven Central, which is like a library of building system online, and using this block. So this is the information you need to identify this library on Maven Central. So the question is, how do you translate this block to the part you need to include in the build.gradle? So here you can see there's a group ID, which is basically the name of the developer, the artifact ID, which is like the library name, and the version number. So the way you do it in Android Studio is just you say compile, and you have a first the develop name, and you have a semicolon, and you have a package name, which is the artifact ID, and again a semicolon, and also a version name. So sometimes, in order to make this app more robust, for example, this version number could change. What if this guy released 7.0? You can always have some wildcard like star here to indicate that any version of this library would do. Yeah. So this could be very useful because a lot of Android application components today are developed by those third-party libraries. Not only those utility libraries, but you also see a lot of UI libraries like all these card library and all these list libraries look very nice, and it might take a lot of time for you to re-implement them. So it is always a good practice to try to see if there is some similar open source project online and try to include them in your application. So yeah, this is the application level build Gradle file, and let's go back to our Hello World app. And the source code, there are also several folders in this module, which is application. You have the build folder, the library folder, and the source code folder. So this is where you have the source code of your application. And in the Java folder, you can see this is the activity you created, and it's pretty simple. It extends the system activity, and you override the onCreate callback, and here you load the layout files, which is defined in this REST folder. And if you go to layout, you can see this activity main created here. And it's pretty simple, and it has a very handy drag and drop interface. You can just drag and drop different components into the screen. And you can also switch to the text mode. Here you can see you have a relative layout, and the only thing you have here is a text field saying hello world. So yeah, Bo will show you a little bit more about this when he's doing the demo. But yeah, this is the way you define a basic Android UI. And you can find some other things in the REST folder as well. For example, the string.xml I mentioned, and here the only thing defined is the app name, which is my application. You can also change it, and also the colors. You can see here by default, Android has defined some material color type for you: color primary dark, and color accent. So you can change those colors, and you can also define other color types. And styles.xml, this is the part where I said you can define your own style and inherit from system styles. And you can see that it is actually defining all these colors and referring to the color defining color.xml. So yeah, this is pretty clean and modular way of defining all these constants so that you don't get messed up when you have a very huge application. So this is a REST folder, and the final thing is the manifest file of the application, which is called Android manifest. So there are several things you need to define in this. First of all, it has your package name. So if you ever change this in a build.gradle file, you also have to, the application ID, you also have to change it here to match it. And application block defines all these application components available in your application. Like for example, here when I have one activity, and it actually has a intent filter inside of it. The reason of its intent filter is that this is the only way in the Android application you specify this activity is the main entry point of the application. So this is like in C you define this is the main, or in Python or in Java you define this is the main function of the application. Basically what this intent filter is saying is that whenever the user click this button on the UI, it will be launching this activity from my application. So if you write another activity or multiple activity exists in your application, and you need to specify which one is the main entry point, you just put this intent filter block under that activity. So if you have any other application components like different activities, different services, different broadcast receivers, you can also define in this block here. So yeah, this is creating a project using Android Studio, and yeah, this I've already covered all this stuff. So also the Gradle building system, all these blocks, and just pay attention to the version number, the program rules, and also the dependencies. So one last thing before handing over to Bo, the Android debug bridge, which is a very useful tool for you to access the device and debug your applications. It's like a client-server architecture where you have a daemon on the device and you have like a server client-server access on your computer. So there are several ways for you to access the ADB. Like for example, you can do it in the terminal. Once you have installed the Android SDK and you have put it into a class path, you should have this ADB tool available. There are several things you could do. You could do ADB devices. So right now I have this devices connected to my computer through USB, and I have turned on the USB debugging. So you can see this device here, and you can also access the file system with it using ADB shell. And this blue hat is the name of the device. So right now I'm in the Linux file system of this device, and you can also check out the SD card, and if you have some files here, you can look at those files, and you can also display the current processes running on the phone, which is very useful if you're trying to debug your application. And you can also do all sorts of things like ADB pull. You can try to pull a file from the file system, which is like the CP, or you can also do ADB push, where you can push some files into the file system. And one last thing, ADB logcat, which is a very useful thing, maybe the most important thing you will be using developing an Android app. It will give you all this log information from your application, and you can also view it in the Android Studio. Here, if you go to Android Monitor, you can see that this is the AB log here. You can specify a filters, like I only want to see some arrow, and only strings with the character arrow will be displayed. And you can also select different warning levels, like you can be verbose, which is basically showing anything, and debugging. This is like the different levels of the logging inside Android. And in your application, you can also specify your log according to those different logging levels. Like for example, this tool called ADB logcat. You can, for example, you can say that log something, and when you say log, you can say log.e, which is log.arrow, which log.i, which is log info, and log.v, which is verbose. So all these difference you made when you are writing this log message will correspond to the different debug levels here, and you can use a filter to look at only a specific types of message. And yeah, so check out this web page for more information. And yeah, actually, one more final thing to mention is Android permission framework. So access to certain user information or sensor will require some explicit permissions. You will think of like all these sensitive things like location, camera, microphone. You don't want any application to be able to access those information. So you have to, as an application developer, you have to declare some certain permissions. And in older version of Android, this is like an install time permission check. The way you do it is you define it in the Android manifest file. Say I want to access the internet in my application, and the users have to accept this when he's or she is installing the app. Otherwise, they will just choose to not install the app. This is not very convenient because you cannot just if I feel some permission is bad, I just can't use the application anymore, which is not very convenient. So starting from Android 6, Google introduced this runtime permission check, which is similar to iOS. So developers now not only need to declare a permission in the manifest file. They also need to request each individual permission in the code at runtime. So you will see those kind of screens right now in your newer Android phones because it was trying to say something, trying to access your context to your access to allow or deny. So the users can do this for each permission at runtime, and later on they can also go into the settings to grant individual permissions and also revoke individual permission from your applications. So this is really a more convenient way for both the application developers and the users. So now I'll hand over to Bo and we'll have some demos for some real apps.